In this section, we're going to be talking about the DDL, that is Data Definition Language, subset of Cassandra Query Language. That is, we're going to be creating and modifying key spaces and tables. That's pretty much it. So let's start with the key space. We already know what this is. It is a top-level namespace. It just is it's a thing that contains tables, and tables contain data. At the key space level, we change one thing: replication. So the replication strategy and the replication factor, but all just having to do with replication. Now, you may sometimes see when you describe your key space, there's this other thing about with durable rights. Don't worry about that. That just allows you to turn off the commit log, but we pretty much never do that. So for all intents and purposes, it's creating a key space, and in that you set replication. That's it. Here's how we do that. Create key space, and then here's our example, musicdb. And in this case, we're using simple strategy, replication factor 3. And then we can switch to it using use. You know, you can actually reference any table from anywhere within CQLSH using the keyspace.table notation. But if you want to have a shorter reference, you can just use that key space. And to drop a key space, just drop it. To create a table, you use create table, whatever, and then you list off this column name, column type pairs, just like this. Boom, boom. Name, varchar, type, varchar, da, 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 da. You have the ability to declare, if you have a simple primary key, you can declare it inline like this. You can say name, varchar, primary key. Done. That is identical to this declaration over here, where we use this sort of postfix notation of declaring it at the end. Most of the time, you're going to be using this syntax just because you're probably going to have a more complex primary key than just a single field. There are 4 different variations of declaring your primary key. And here they are, all 4 of them. We've seen examples of some of these. Here is the simplest case, where you just have one field in your primary key. If you only have one field in your primary key, that is your partition key, as we can see here in blue. So why can't we have clustering columns without a partition key? Why do we have to have a primary key at all? Well, we use the primary key, at least the partition key component, to do what? What if we didn't have it? We wouldn't know where in the cluster our data is, because that is the value we hash using the murmur3 hashing algorithm by default to actually figure out which node holds the data. So at least the partition key is required. So you're going to have at least one field. So this is what that looks like when you only have the partition key. You can have a composite partition key. That is, you're just saying, hey, let's use more fields to give this component of the primary key some uniqueness. Or maybe you add some detail in there to chop your data up into smaller partitions. I'm going to skip over this one and go down here to the last one first. So we have, in this case, we have a composite partition key and multiple clustering columns. You can think of that as composite clustering columns as well. Now back to here, I'm going to point this one out specially because in this case we just have one partition key and multiple clustering columns. If you do not pay attention when you create your tables, it's very easy to think in your head, oh, I'm declaring this first column and this second column, and I'm intending for those to be a composite partition key. But as you can see here, if you do not add additional parentheses around this first piece, then only the first column will be the partition key, and the remaining pieces will be clustering columns. So you have to keep that in mind when you're designing your primary key. Here are some examples of 2 tables. On the left, we have create table albums by track. Notice that the primary key has a simple partition key, and how many clustering columns? 3. We have 3 clustering columns. This table, tracked by album, let's first look at the primary key. What kind of primary key do we have here? What kind of partition key is this? This is a composite partition key with one clustering column. We've also declared two of these columns to be static. Now we saw that in the example, what that looks like, and let's keep going. We have a pretty rich list of column types. Now one thing you will notice is that when you're declaring these, such as like a text or varchar, you will not specify the length. And the same thing with like decimal, you will not declare the number of decimal places. Part of that is because we have to look back at, well, why do we kind of take that for granted, or at least I do, with relational databases. Like, that's just what we do. And being more specific is more efficient. Well, why? The reason it's more efficient in those kinds of databases is because they have to leave little holes on disk for where that data would go, even if it's null. And so we have to know exactly how big that data would be. But with Cassandra, we don't do that. With Cassandra, we're only writing the data out after it has been in memory and nice and organized, and then we flush it out to those SS tables. So there's no point in us declaring those and having specified width or precision. Some of the columns you may be interested in, we touched briefly on counter type columns. These are interesting. INET, if you want to store an IPv4 or v6 value. We also have this tuple, UUID and time UUID you might not be used to, and we're going to see that in just a minute. In case you're curious, varchar, text, these are actually aliases for each other. If you need to change your table, you can use the alter statement. Here we have some statements for adding, changing a type, and dropping a column. Now there's some nuances here that you have to be aware of. You cannot add fields to your primary key, nor remove fields from your primary key. If you need to alter the primary key, you have to create a new table and move it all over. And if you think about it, it makes sense, because what you're ultimately saying is, hey, rewrite all of my data. And yes, right now you have to do that manually. Hopefully in a future version of Cassandra we'll automate that somewhat, but currently that's a manual extraction. Some people ask, is there a tool to do that or something like that? Not really, although Spark does a really good job if you're using DataStax Enterprise, or you can write your own little program just to select and insert. If you need to drop a table, you can use the drop table statement, also drop key space. Another statement that we haven't really reviewed here is truncate. So one little handy nuance is that in the Cassandra YAML, if you have enabled auto snapshot, which, well, it defaults to true, so it's on by default, then if you try to drop a table, drop a key space, or truncate a table, the data will appear to go away. But under the hood, Cassandra has actually created a snapshot of that. Now, the one subtle consequence of that is that in development, if you're running tests, and in your test, you truncate a table, reload the data, truncate a table, reload the data, truncate a table, reload the data, which is a very common routine. Eventually, you'll truncate the data and try to reload it, and the disk will be full. And you're going to be thinking, well, why is this full? Well, if you go dig into it, you'll find out on disk that there's actually backups of every time you've loaded data. It's very easy to get rid of those. Just run node tool clear snapshot, and it will delete all snapshots. Or in development, you can just go into the Cassandra YAML and all of your nodes and turn off auto snapshot. In production, however, you should never turn that off. And here's why. How many times have you been working on your system, working on your code, and you're saying, okay, I'm going to rerun these tests, I'm going to manually truncate this table, and you do that, and then you think, wait a minute, this is the development environment, right? And it's not. Auto snapshot can really save you in that case. So definitely leave it on in production. Cassandra, as we saw in the demo, lays out your data on disk sorted. Sometimes it's handy to specify the sort order. Now by default, it's going to make everything, all of the clustering columns ascending. So in this case, we'll see performer ascending. By default, it would have been, if I had specified nothing, year ascending, title ascending. That's what it would have been if I had said nothing. Here we're using the clustering order by statement to set the sort order of these fields. Now notice these are only our clustering columns. See, performer, year, title. We don't have the opportunity to specify the sort order for non-clustering column fields.